Hello, this is Professor Teresa Pelkie. This is Session 14, Part 1, the Insert, Update, and Delete Statements. In this session, we'll look at 3 different topics. In this video, we'll work with the Insert, Update, and Delete statements. These are Data Manipulation Language, or DML statements. These statements are used to change the contents of a table. In Part 2, we'll use Data Definition Language, or DDL statements, to define and modify tables. In Part 3, we'll look at keys and indexes and how they are used with a database. To get started, we'll look at how you can add new rows to a table. If you are working with MySQL Workbench, you can simply type the data for a new row into a table. Start by running a select statement for the table. That shows the result grid. In the bottom row of the result grid, you'll see the null indicators. You can just click into the first column on the left side of the bottom row and start typing the values for the data. On this slide, I've already started entering data for a new row. I first typed the advisor ID value of 9, then tabbed into the next column and entered a value for the title. I can continue to tab through the row and enter values. After you get done entering all of the values for a row, the row is not actually stored in the table until you save it. You can see that it is not stored by running another query for the table in another query tab. To save the new row, you need to close the tab where you entered the data for the row. When you close the tab, the Close SQL tab pop-up shown on the left side of this slide is displayed. You need to click the Save Changes item to save the new row in the table. When you click Save Changes, the Apply SQL Scripts to Database panel shown on the right is displayed. You've seen this panel used several different times in this course. This time, the panel has an insert statement that will be run when you click the Apply button. So now you know how to add a new row to a table using MySQL Workbench. As useful as it is to be able to add data using Workbench, the real action happens with the insert statement. To work with the database in your application, you need to code the insert statement in your application, similar to what was shown on the previous slide. Here you see the insert statement that adds a new advisor to the advisors table. As you can see, there are 3 parts to the insert statement. First, you have the clause Insert Into. That clause is followed by the table name. In this example, the table name is not schema qualified, but you can use a schema qualified table name if necessary. You might be able to specify a view name instead of a table name. If the view is built over only one table, you can use that. But if a view is built over more than one table, for example, if the view contains join statements, you might not be able to perform an insert on that view. The reason why is because the database engine might not be able to determine which of the underlying tables needs to be updated. As a general rule, it is better to not use a view as a target of an insert. Use the underlying table itself. If there is more than one table in the view, use another insert statement for the other table. Following the Insert Into clause, you put a column list enclosed in parentheses. The columns are the column names that are defined in the table. When you perform an insert, you must supply a value for every column in the table. If a column is defined in the table as being null capable, or the column is defined with a default value, you do not need to include the column in the column list unless you want to specify a value for the column or override its default. To put it another way, if a column is not null capable and it does not have a default value specified, you must include the column name in the column list. Following the closing parenthesis character for the column list, you put the keyword values. then an opening parenthesis character. Inside the values list, you enter a value for each of the columns that are listed in the columns list. The values that you supply must be valid for the column. For example, the advisor ID is defined as a tiny int data type, which is a numeric data type. If I try to enter a character value for the advisor ID, for example, if I try to enter the value A123, the insert will fail. There are some other things you need to be aware of when specifying values. In this example, the title column is defined as an enum data type, meaning that there are only a few values that can be specified. For the advisors table, the possible values for title are the abbreviations for Doctor, Professor, Mr., Mrs., and MS. Another issue is with the character columns. In the advisors table, there are the F-name, L-name, room, phone, and email columns. All of those columns are defined as var_char fields, with lengths specified as 10, 20, or 30. If you supply a value that is longer than the maximum allowed for the column, you get an error message. So how are you supposed to use an insert statement like this? As an example, you might have a PHP web page. After the user enters data into a web form, the PHP script could move the form values into the values list of the insert statement. You would then perform the insert using the connection to the database. When you invoke SQL statements in an application like PHP, you should monitor for, capture, and handle any errors that occur as a result of invoking the statement. For example, if the user enters a non-numeric value for the advisor ID, or if the user enters more data than will fit into a column, an error message will be returned to the PHP application. If you don't handle the SQL error in your script, the SQL error might be displayed on the web page. You've probably seen that happen on some websites. It is usually a sign that the script was not carefully coded to handle the errors. When you are coding insert statements for an application, you should consider putting the inserts into stored procedures. Many times you'll see an insert statement being built up in a script using a long series of concatenations. That is almost always a bad idea. As an alternative to calling a stored procedure or using concatenation, you can always look into using prepared statements. With a prepared statement, you specify the insert statement, but rather than concatenate the values into the value list, you set the values using parameter markers. Here's something else you can do with an insert statement. You can insert more than one row using the same insert statement. To do that, you create a list of values lists. In this example, I am inserting two rows for advisor ID 9 and advisor ID 11. Note that the lists are separated by a comma. What I mean is that the end of the line for advisor's ID 9, following the closing parenthesis, a comma is used to separate that values list from the next list for advisor ID 11. Both of the values lists must contain values for the columns specified in the columns list. Also, the data must be valid for all of the columns for all of the new rows. This type of insert is an all or nothing insert. If a data value in any of the columns in any row is invalid, then none of the new rows are inserted. Some database management systems might not allow this type of insert. Before coding an insert like this, check the database documentation to make sure it is allowed. MySQL does allow this type of insert. There is no limit specified for the number of rows that you can include in the insert statement. There is another form of the insert statement that is used to copy rows from one table to another. The upper left corner shows one form of this insert. In the upper left example, a column list is specified. The column list is for the new advisors table. In place of the values keyword and a values list, you can use a select statement. In this example, the select is followed by a column list, and the data is selected from the advisors table. The select statement can be a simple select, like what is shown here, or it might be more involved. For example, you can include a where clause so that you only select certain rows in the select from table. You could also use a join if necessary. The columns that appear in the select from clause must be the same data type as the columns in the insert into column list. The column names do not have to be the same. The values from the select from are mapped to the insert into columns based on their position in the column list. In the lower right side of the slide, you see a simpler way of specifying an all column type of insert into. In that figure, we are using the select all type of select. Notice that there is no column list specified for the insert into clause. When you use the simplified type of insert into, you must be sure that there are the same number of columns in each table and that columns are in the same position and have the same data type or a compatible data type. The table that you specify as the insert into table must already exist. In part 3 of this session, you'll see how you can use the DDL to easily create a new table based on an existing table. There are a couple of ways that you might use this type of insert. First, if you are developing an application and need to get a quick set of test data, you might be able to copy data from a production table into a test table. Another use is when you need to extract a subset of data. For example, you might want to extract data from a transaction file based on a date range to create a backup table for the day, month, or year. Now let's look at the delete statement. As implied by the name of the statement, it is used to delete or remove rows from a table. The delete statement is very simple. Just delete from followed by the table name. The problem with delete is that once it runs, the data is really gone. There is nothing in the SQL language specification that says that there must be a way to recover deleted data. It does not matter if the deletion was intentional or accidental. Because of that issue, MySQL Workbench by default prohibits you from running a delete statement unless there is also a qualifying where clause. What that means is you specify a where clause to limit the rows that will be deleted. The assumption, which is usually correct, is that you almost never want to delete all the rows from a table. You will usually want to delete only a subset of the rows. The subset to be deleted is specified in the where clause, which can be as simple or complex as needed. So what you see here is a delete and the results of trying to run the statement in Workbench. The error code tells you that the delete is not allowed, but it also tells you how you can configure Workbench to allow a delete without a where clause. You'll see the configuration step on the next slide. The picture in the middle of this slide shows a delete statement that has a where clause. This is the way you'll almost always code a delete statement. If you do want to delete all rows from a table, you can use the truncate table statement shown at the bottom of the slide. The truncate table statement does not require a where clause. Like a delete statement, it permanently removes rows from the table. After the truncate table runs, you are left with a table that has no rows in it. If you want to delete the entire table from the database, you use the drop table DDL statement. Truncate table is optimized for quickly removing all rows from a table. You can get the same effect by using a delete statement with a where clause that encompasses all of the rows in the table. The difference between truncate and delete has to do with internal log files that most SQL database management systems use. With a delete statement, each row that is deleted is logged. With a truncate, only the truncation is logged, but not each individual row that is removed from the table. For small tables with only a few thousand or fewer rows, you might not be able to detect a difference in the performance of a truncate compared with a delete for all rows. But if the table contains millions of rows, truncate, which takes only fractions of a second to run, will be much faster. A few minutes ago, I told you that by default, MySQL Workbench will not let you run a delete statement unless it has a where clause. It turns out that there is also a restriction when you run an update statement in Workbench. Since we will be looking at the update statement next, let's take a minute to change the default settings in Workbench so that we can run update statements without any restrictions. In MySQL Workbench, click the Edit Preferences menu Items. That will open the Workbench Preferences panel. On that panel, click the SQL Editor item in the column on the left. On this slide, it is the item that is highlighted in red in the top left part of the figure. On the SQL Editor panel, locate the Save Updates option. It is shown on this slide as the item at the bottom of the panel, also highlighted in red. You might have to scroll down in the SQL Editor to see the option, or you can resize the panel. By default, the Save Updates option is checked. That is what is used to control what we can do with the delete and update statements. Uncheck the option, then click the OK button. You now need to close and reopen Workbench to put the changes into effect. If you change the item, but just stay in Workbench, the change won't be in effect until the next time you open Workbench. To finish up, we'll look at how you can update or change data in a table. The update statement has two required clauses and an optional where statement. Although I said optional, the truth is, just like a delete statement, you will almost always have a where clause when you use the update statement. The first clause is the update clause. It contains the name of the table that you want to update. The set clause is a list of columns that you want to assign new values to. The clause is composed of one or more name and value pairs. In this clause, the equal sign is used as the assignment operator, meaning that the value that is specified to the right of the equal sign is assigned to the column name on the left of the equal sign. As shown in this example, we are updating only one column, the room column. We are changing the room number from the current room number, which for this advisor was O100, to the new value of CS100. You can update more than one column at a time. If you have more than one column to update, just put a comma at the end of the first value, then start the new assignment. In this example, the comma would go after the two closing parentheses characters on line 2. Don't repeat the set keyword. Just start the next name and value assignment. In this example, the where clause is used to limit the update to just one row, the row for advisor ID 1. We know for a fact that only one row will be updated since the advisor ID column is the primary key. Because it is the primary key, the value for the advisor ID will be unique in the table. The select statement shown on line 5 is not part of the update. It is shown here just so that the result grid will be shown. In our final example, we'll look at an update statement that updates multiple rows. In this example, we are changing all of the advisor's room numbers. The current room numbers start with the character O-. We want to change the room numbers so that they start with the CS-. Perhaps a benefactor paid for part of the building, and now they want to name a wing of the buildings for themselves. On the previous slide, you saw one way to do an update like this. You simply run a series of update statements, one for each advisor. That would certainly work, but you can also update multiple rows at once. The where clause is used to select the rows to be updated. In this example, all of the rows with a room number that start with the characters O- are selected. After selecting all of the rows that meet the condition, the set statement is performed. It's important to note the order of execution here. The where is performed first, then the set is performed. That is so even though the where clause follows the set clause. The reason why I am pointing that out is so that you understand that the set operations are only performed on rows that are selected based on the where clause. In this example, we are updating the column in the set clause that is used for a selection in the where clause. It is entirely possible that you might have a where clause in an update statement that selects no rows. In that case, nothing is updated. The statement does not fail or cause an error, since it is not an error to not select anything. As on the previous slide, the select all statement on line 5 is not part of the update. It is just included so that we can see the result grid after the update is performed. In the next video, we'll look at how to use data definition language statements to modify tables.